Hello, everyone. Thank you for participating in our today's seminar. Thanks God it's a seminar again, right? Of course, thanks for the efforts that the government has been spending from the beginning of the pandemic. We should mention this, of course. My name is Yahya, and I will be the speaker, one of the speakers of today's seminar. And as you know, we will speak about the integration of DJI drones with UGCS software and how we can benefit from the artificial intelligence that UGCS has been investing and using with their software. So I have with me my colleague Pavel, and he will share with me a part of this seminar. So let me introduce myself. My name is Yahya, and I work at Advanced Media as a Creative Solutions Engineer in Creative Solutions Department. And before we start, let us give you a brief introduction about our companies. AMT Advanced Media established in 2002. The main focus was in finding solutions related to media products, videography, audio, lighting, and so on. And Advanced Media was one of the first companies that start to invest in drones technologies. And on top of that, we are a DJI, an authorized DJI distributor, and we have a service center for DJI products and for the other brands as well. Pavel, if you'd like just to come over for a little and just tell us about your company as well, please.
Absolutely. Thank you, Yahya. Sure. Good morning. NNTC has been established in Dubai about 5 years ago, and we are the part of international group with headquarters in Russia. Our head company, Krag, is operating in Russia for the last 26 years, and currently it's one of the biggest IT systems integrator in the country. We do have operations in Turkey, where we run a cloud data center for local companies, mainly for financial sector. We have an office in Bahrain who is focusing on IT security operations. And here in Dubai, NNTC is focusing on new technologies like artificial intelligence, facial recognition, drone management, and many others. Virtual reality is one of the strongest expertises we have. One of the reasons why we're here today, in our group we have a company called SPH Engineering. They're located in Latvia. It's a European established company. Their only job is to develop the product related to software products related to the drone management. Basically, they developed UGCS software, which is flight planning, mission planning, flight automation software. UGCS also is being used for drone shows. It's one of the interesting pieces that is the same technology which is actually applied to the control of hundreds and thousands of drones at the same time. And Atlas is an AI tool for the data processing which gathered from the drones. So that we will cover this today. A bit later once Yahya finishes with the hardware piece.
Sure.
And that's it. In 5 years, we managed to do some nice stuff in this region too. So let's do more.
Thank you, Pavel. DJI itself, we should give a little time to speak about DJI as well. DJI established in 2006. The main focus was in manufacturing the flight controller of the helicopters for hobbyists. And then time by time, it kept on developing. And the turning point of DJI was in 2013 when they introduced the Phantom series. It was all-in-one solution from DJI. Then they introduced the Mavic series. And now in 2021, they are in the top. They have a lot of solutions in terms of industrial or videography, photography, and in terms of consumer as well. So as we know, the drones are being used in almost every field right now. We are in 2021. We have inquiries from every field, like for the oil and gas, for the inspection, for the photogrammetry, for the surveying, for the entertainment as well. There is a lot of usage of the drone, and it's because it is a powerful tool, and it's being using as well in the agriculture for the crop monitoring as well. So if we are speaking about a solution, so a solution from a drone should be with 3 mandatory parts. The first one is a platform, which is the drone, the body, of course, and the second one is the payload, which is the camera or the sensor. Sometimes it's mounted separately, sometimes it is inbuilt with the drone, like the Phantom or the Mavic Enterprise series. And we have, on the other hand, the software, which have 2 sides. One is for mission planning, if we want to fly, if we don't want to fly the drone manually, and the other hand, we have the data processing software. In our case, we can use DJI Terra or UGCS Atlas to be more specific. So if I want, since we are speaking about how to make the surveying smarter with a drone, if I want to define the surveying in just 1 slide or 1 to 2 minutes, it will be not enough, of course, because it is a huge field. It is very complicated. But to summarize it up, the surveying, the main point of the surveying is to collect the data from the ground in order to have it for planning, for measurements, for constructions, and so on. And the photogrammetry is a branch from the surveying itself. Hi. The photogrammetry is a branch from the surveying, and it's been used from a long time. It's not something new. It's been used using the satellites, the airbornes, and recently they started to invest in drones, or to be more in general speaking, in UAV, unmanned aerial vehicles. And the photogrammetry is photogrammetry, meaning photometer. So I'm able to have measurements from a photo, right? So this is a good example of a photogrammetry using a drone. In this video, we can see a topographic mapping. This is a DJI Terra software, and this is a 3D reconstruction from the software itself. We have the full control. We can take measurements. We can have a 3D model of a building. So you have now digitalized world from the real digital version from the real world, right? The photogrammetry application or the surveying application, they are a lot. We can use it in topographic mapping to have a topographic map that is showing hills, mountains, villages, towns. We can use it in the cadastral surveying to show the boundaries of a properties, for example, for a town. We can use it for construction, agriculture, for crop monitoring, health, geological investigation, accident reconstruction. There is a lot of application that we can benefit from the drone itself using the photogrammetry applications. This is an example. We have here the cadastral survey. From here, we took this model from a drone, then we took it to other third-party software to just highlight the properties of each house, for example. And we have another example of a 2D. This is 10 square kilometer from a drone. It's not playing. It seems like, this is 10 square kilometer from a drone. This is amazing. You can cover this area in just one working day using this drone with the P1s that I will speak about in the next slides. So yeah, the studies showed that a 120 hour of work from the traditional surveying, I can do it in only 16 hours using a drone. So thus I'm enhancing the efficiency, I'm reducing the cost, I'm enhancing the safety, and I'm having a digital powerful insights that I can use it like I said, we have now a digital copy from the real world, right? What we can get from a drone, we can get obviously a lot of data, because there is a lot of solutions, a lot of payloads that we can mount using this drone. We can use an Rgb camera to have 2D or 3D models. We can use a LiDAR solution to have a 3D point cloud. We can use a thermal solution to have a thermal map. And we have the multispectral solutions that is being used to monitor the crop health. This is for agriculture, purely for agriculture purpose. So I want to focus on three solutions in this seminar. We have the M300 with different solutions, and we have the portable solution, which is the Phantom 4 RTK. The Matrix 300, and I can describe it that it is the most powerful drone in the world right now, because it's combining the performance with the intelligence, with the safety, to give you this lovely, powerful drone. It can fly to up to 55 minutes with no payload, but still this is something remarkable from DJI. It have an omnidirectional sensor to enhance the safety. It has an IP rating of 45, so water and dust proof, and it can take at the same time 3 payloads, increasing the possibilities of the solution that you are willing to have from a drone. So amazing drone. And of course, it has the RTK antennas to just make the drone more accurate and more stable while flying. For the photogrammetry solutions, we have the new payload from DJI, which is the P1. I have it here. DJI P1. Now P stands for photogrammetry, obviously. So this payload is made purely for photogrammetry missions. It comes with 45 megapixel, full frame sensor size, and it is compatible with three available different lenses, increasing the possibilities of the scenarios that you are flying with the drone. Like we have the 24 millimeter, we have the 35, and we have the 50. The package comes with the 35 millimeter, which is, we can use it in almost every scenario with a photogrammetry mission, like in the low elevation, in the high elevation, it will work with us. In the other hand, we have the LiDAR solution. So we have the photogrammetry and the LiDAR solution. We don't have it, unfortunately, the L1. We can see it from here. It's the concept of L1, of the LiDAR. So we have a pulse will emit from the emitter, and it will bounce off an object. The sensor will measure the distance, and we will mark a point in this distance. So we have a point clouds from the result. So the L1 supports 3 returns, meaning that each pulse will penetrate objects. Of course, it have to be not every object. It have to be like a glass or leaves. But this is amazing. The L1 solution or the LiDAR solution is amazing in the vegetation scenarios, since we will get a triple return from the payload itself. So we can measure the vegetation height. There is a lot of applications that we can use with the LiDAR. And here is a video for a building. This is for the DJI. They are working on it still. So and a nice feature that you can consider if you want to use the L1, that it's not dependable on the light environment, right? Because it's using laser. So you can have missions during night, for example. If you want to fly it in the normal days, it have an RGB camera as well. We can use it for two things. We can use it to colorize the data because the point cloud are like black and white. So we can colorize it using the RGB camera. And you can use it as a photogrammetry solution. So because it is 20 megapixel 1-inch sensor. So we can consider, with L1, now you have both solution, LiDAR and photogrammetry. For the last product that I want to speak about is the Phantom 4 RTK. This is an entry level for the photogrammetry, the portable solution. It have a 20 megapixel camera with 1-inch sensor size. It can fly up to 30 minutes. So this is, if you're not so professional in the photogrammetry or surveying, this is the entry-level solution from DJI. And it supports RTK because it have the RTK antenna as well. So from here we can see if we want to go to the entry level, you can choose the Phantom 4 RTK, go to the right if you want something more efficient. So Pavel,
yes.
I believe if we want to have the high accuracy output from a drone photogrammetry mission, we have to plan the mission in a very professional way. So I believe UGCS will help us achieve this, right?
Yeah, sure. I will show it later on the live system. The idea when you plan a photogrammetric flight, the most important is to understand what GSD you want to achieve, right, the resolution. So the beauty of UGCS as a software for that the photogrammetric flight planning in UGCS is being done in just a couple of clicks. All you need to know is a payload and the resolution you want to achieve. And then just in 2 clicks it will be shown. We'll do it live. Just let's finish that. Okay, thank you.
Sure.
So yeah, going back to the drones, I mean, drones are very nice devices which helps you to do a lot of tasks, right? The only interesting thing when you look into the current industry, and correct me if I'm wrong, and how does it look for you currently, most of the customers we meet so far is basically getting a drone hardware and getting a pilot and then start the operations. And that's what you see on the slide. This is typical operations which we see in our customers today. So it's basically manual flying, manual processing, manual reporting. Yes, it's still more efficient than many other ways to do the job, but the question is, can it be done really better? What we usually offer is to automate 2 pieces of this process. To automate the flight planning and flight execution to make sure that flights are executed constantly without errors and automatically, so the pilot is just becoming a supervisor in this case. And the second piece is, say, much smarter pieces. So during the flight we will collect the data from different sensors. It can be cameras, LiDARs, or some other sensors which we can integrate with the drones. And the second piece is the most actually time consuming, right? Imagine, simple example, you flew the, say, 5-6 square kilometers of the territory and you have, I don't know, 15,000 pictures. Now you need to find an object on these 15,000 pictures to count, for example, number of buildings. The question is, if you do it manually, how much time it's going to take? It's basically the analysis engineer has to manually look through 15,000 pictures, marking the buildings and reporting them somehow. But what if we need more complex tasks? It's not just accounting. For example, we need to classify the buildings. So we need to say, okay, which buildings are new and which buildings are old, to sort them according to the location or to the groups or to the areas. So that really becomes a kind of enormous task. Yeah, you did the flight very well. It was quick, right? 5 square kilometers, maybe the pilot did it in a day. But the engineer who is analyzing it and reporting it back to the concerned departments, basically these guys will spend another 2, 3, 4 weeks to complete the report. So what we do with Atlas is we basically use an AI capability of the modern computers and software to make sure that we can automate this process of object detection, process of the change tracking, process of the mapping, stitching, and all these things together to make sure it's quick. And the most important, we can set up custom reports. So for example, if I want to know the number of date palms in the area, or I want to know the number of diesel generators installed in the area or over the facilities, I can automate the report, and just with one click in 10-15 minutes, the system will give me an answer. So that's the whole concept. So basically, what we implement at the end of the day, and that's what you see on the screen, is a complete pipeline from the flight planning piece to the final report, which can be delivered to the concerned departments. So typically, this pipeline is being set up in a drone department or drone group who is responsible for that, but that's complete thing from A to Z, just from getting the task from the department who is interested in the data to giving them a complete report in a matter of days. So that's two tools which we are going to use. If you look at the tools itself, so UGCS is a pretty much simple piece of software. It's been on the market for the last 5 years, and we sold thousands of copies worldwide. It's been used by the smaller companies of 2-3 people only who is doing simple inspection jobs, and it's been used by the huge inspection companies, like one of the biggest operators in the United States, who are inspecting about 45,000 telecom towers in the country. It's all done by means of UGCS. Sometimes for bigger customers, we really customize it. For example, if you have the requirement to have some unique feature, we can add it because we are basically the developer of that. We own the source code, and many customers do ask for that. If you look at the features of UGCS, the main thing is that it's a basically flight mission planning tool, which is completely 3D. It's really immersive. It's very simple to use. There are a lot of flight planning tools which are predefined, so it's not just a waypoints which you put manually. Just give me a second. I will share the real system, so I'll show you what can be done. It takes about a couple of days for the pilot or operator to learn how to use it, and actually even on the first day, after 2-3 hours, the person can easily fly automatically with that. We do support any drone, including DJI, and DJI obviously as a market leader is a main supporting thing, but we do support all other brands. We support Parrot, Lockheed Martin, open source like Ardu Pilot and Pixhawk based drones. It also can be used as a command and control center. Is one of the versions of the software allows you to have one centralized management for all drone operations with video streaming. And with Yahya, we will show you how the video streaming works today. One thing which we are definitely proud of, UGCS has the lowest latency in the video streaming from DJI drones. In a good environment, we can deliver better than 200 millisecond latency in a video stream, which makes it possible to use it for the real-time surveillance and security operations. So like if you run in a security department who wants to secure a perimeter of the area or whatever, that can be a real case. One of the examples of users of this is Dubai Police, who is using exactly the same software for the command and control center with video streaming. What else? Yeah, there are lots of tools like no-fly zone management, post-flight log analysis, so you can see what the pilots actually did in the last flights. You can see all the flights recorded. So it's quite sophisticated in terms of the functionality. It also has a simple mapping capability. There is a special module. For example, if normally you rely on public available map sources, but the problem with these sources, they are not really high resolution. And if you really need to plan some precise mission, for example, to fly in front of the wall of the building, obviously it's impossible to do with the public map sources because the resolutions are low. UGCS has a built-in mechanisms which can build high-resolution maps from the same drone you use for the main service. It's just make a small area scan and get a high-resolution map inside, and you can connect the source into the system. It also works with elevation maps, so it's just complete thing. Let me show you how does it look like. It's really simple, and I like the way it's really works. What you see here is basically the main interface. It's a client. This client is connected to UGCS server, so it's a centralized architecture where you can have multiple clients connected. Yeah. where you can have multiple clients connected to one centralized system, and that's how basically command and control center is implemented. So we can have one centralized system with all the flight routes, with all the flight logs, and with all the maps, and multiple operators can actually work on it. So just to give you an idea how it looks like, this is Al Qudra Lake, so it's not far from here, Dubai. If I want, for example, to do the photogrammetry scan of this lake, so all I need to do is just to create a new flight route and select the type of the drone. I will use emulator for now because we obviously can't fly in this room. So these are parameters, the basic parameters of the route, which can be set up, like the maximum permitted altitude, the starting point of the drone above the ground, actions on the different safety actions. They've been accounted here. Like there are a lot of safety features to make sure that the flights are safe. We have a lot of geofencing, no-fly zones. We have different actions of, for example, in the loss of connection with the drone, loss of GPS, battery discharges. All the safety features and automation is being managed here. In fact, after 5 years of experience, we definitely, our customers did have an accident, right, because of the different safety features. Sure. It was a long route to the development. Today, all these accidents were accounted and managed through the settings, so you can really predict a lot of things which can happen to the drone and to make sure that it's safe. Yeah, so this is how we create the safe. We want to, I mentioned about automation of photogrammetry. That's how photogrammetry flight route is being automated. All I need to do is just to show the area, say like this. And that's it. And then I select the payload. Currently it's emulation of GoPro here, kind of simple thing. And I want to set up the resolution, right? So the resolution per pixel of on the ground. The camera is being controlled automatically, so the pilot will not do anything actually. The system will do everything automatic. What you see now, the system is actually automatically built the flight route, and it's ready for use. You can set up the overlap of the images, so to make sure that the stitching and photogrammetry restoration tool will work well. One of the things here is to say where do we fly, above ground level or above mean sea level. If we do the flight around mean sea level, you are also getting the elevation profile of the area. Not only the flat stitched map, but also you can get three-dimensional elevations from the same data, which is very useful if you want, for example, even in UGCS, public sources are not really available with elevation, not many. So like this lakes, you see now the area is flat, right? If we do scan it with AMSL flight and we reconstruct the map from the drone data, we will have complete three-dimensional view of this place with a high resolution, which can be used for later surveys. So that's no-brainer. The route is ready. We just can move it a little bit. Yeah, we just now take the drone, upload the route into the drone. It goes to the first waypoint. If the waypoint is a little bit in different locations, there is also a way to add the starting point manually to make sure that you are starting the drone in the right place where you want it to be started. Even if you don't mark this route, it's very simple. Wherever you place the drone, it will fly to the first waypoint, but to make sure that there are no obstacles. Yeah, then we click ARM and auto mode. At this point, my pilot job is done. All I need to do as a pilot, I just need to supervise how the drone flies. That's very simple. And in several minutes, the photogrammetry scan will be finished. The drone will land. We can get the data and process it in Atlas or any other data processing tool. So that's really that simple. There are a lot of tools for the flight planning here. There is a standard area scan. You can do the circle scan around the object. You can do the perimeter scans. It's all the flight planning tools which are available here. One of the unique features we have is a facade scans. Facade scans can scan the vertical facades of the buildings, or you can scan the chimneys or towers to fly around it. So it will go up and down to get the pictures of object. Corridor mapping, for example, if you need to map very wide road, which is 100 or 200 meters wide, or maybe the area, it will be like a wide corridor which will be mapped by the drone in a snake manner. There are two tools specifically designed, and that's an interesting story behind that. There are this creeping line tool and expanding square tool was specifically designed by the customer request several years ago. There is a very large non-profit organization in Russia which are basically looking for the people who got missed. And you know, the country is big. People got missed in the forest. Sometimes kids got missed in the forests. And this organization is looking for they're searching people until they die, right? So they specifically asked us to add two tools into UGCS for the search and rescue. The creeping line and expanding square are the most efficient flight planning tools in the search and rescue operations. By the way, if you think about what they use Phantom drones, mainly Phantoms and mainly Mavic Enterprise with thermal cameras, just to deploy many of them at the same time in the search area and within a day or two, because basically the time is counting by hours. And they basically scan everything around to make sure that they can't find people. It's from different places, like in a layers. You can see it here. You can add your round ones, as I mentioned. There is an integration with ADS-B receiver to make sure that you are not interfering with the real aircraft. So the real aircraft, if you connect ADS-B receiver to UGCS, you will see real aircraft on the same maps along with your drone operations. And also there are a lot of tools to see the recorded flights, like what pilots were doing in the past, so statistics and so on. So that's very straightforward. Should we take a look at the video streaming now?
Of course.
One quick question, Pavel.
Yeah.
What happens when the drone runs out of battery in the middle of the mission?
There are multiple settings here. It's a part of the safety settings which I mentioned already. So there are ways to return drone to the starting locations, or there are ways to land the drone in a location you wanted to land. And once you land, you can replace the batteries. And the good news that the system will continue the flight from the last point where the drone stopped. So it basically allows you to have one very long mission and just to replace the batteries at one place at the charging station, and the mission will continue from the same route. We recently did this exercise. We were scanning the water treatment plant in Alvarsan for Dubai municipality, and that was exactly the case. It's a big plant, like more than kilometer long and kilometer wide. It takes basically lots of time. So it took us about probably 6 hours to do that. But the operations were done from one single point. We were basically sitting in one place and just changing the batteries. The drone would come, land, we change the battery, in 2 minutes it goes again. It was really very, very quick. Yeah.
Okay. Can I know the expected time to complete?
Yes, absolutely. You can watch it in the parameter of the route. If you look this window, what you see here, you see the distance, the total distance of the route. You see the estimated time of completion. You see the elevation profile available from the maps. And obviously, it depends on the speed of the drone which you set up in the scanning tool, right? So it's all there. So it's obviously you will know exactly. You would know all the altitudes which are calculated. You see, this is photogrammetry tool, right? The altitude of the drone is automatically calculated by the system. It's not me who said it, right? It depends on the resolution and payload. So you see all the elevations here, above mean sea level, above the ground. So it's all calculated. You can see that. Yeah, number of waypoints, all this stuff is here. Any more questions?
Yes, thank you for this presentation. I want to ask you about how we can turn on the obstacle avoidance during the flight. If this working in the new version?
So that's a combination of both functions from the drone side and from the software, right? So one thing which I want to mention here, UGCS is not controlling a drone in real time, right? It's an autopilot of a drone which actually flies, right? What we do, we prepare the flight routes for the autopilots. We do not actually need a connection between the drone and the UGCS when it's operating. I mean, illogical, right? We do want to have it to monitor it, but it's not necessary. So mainly obstacle avoidance is on the drone side. It's a function of the drone. And I think M300 in this is one of the best machines available in terms of the obstacle avoidance. But the software accounts for that. So if the drone has obstacle avoidance capability, the software will know about it. So it can be managed. Anything else? Yeah?
Just a second. Because we are live as well, so if you just...
There are situations that we fly in the mountains,
yes,
and then we would be disconnected to the with the drone.
Yeah.
So is there any option that we can fly without connection? So it flies without, when we lose the connection with the drone, it starts continuing the mission.
Yes. So here is the thing. When you create a flight route, you can see it on this particular screen. So action on a loss of RC, right? So basically, it's an action of the drone which you set up on a loss of radio connection. You can go home, you can land, you can continue, you can wait, or do not do anything. So it's like it's your selection. You can fly without the connection. Yes.
Is that possible to give them the time, for example, 60 seconds, continue 60 seconds and return, or 120 seconds?
Yeah, this has been set up here. So basically you, in a drone profile, if we go deep into the configuration, in a drone profile in UGCS, you can set up the timeout. If the connection is lost, how much time should pass before the drone will take specific action?
Correct.
So typically, if you are flying in the mountains and you do know that the connection can be lost, right?
Yes.
You just select the option, then you continue the mission. And that's it. Okay. But obviously in the mountains, when you fly like this, you need to have a precise elevation profiles, not to collide with that. Yeah. Exactly. But that's second thing. But again, it can be done even in UGCS. You can do the mountain scan from the top.
Correct.
And then just make the map within elevations and plan the mission accordingly. Or another thing which we do, and that's very specific to what we do with SPH, for DJI drones, we have a true terrain following system. We basically install a radar sensor on the drone itself, integrate with the drone's hardware, and in UGCS there would be an option to say, I want to fly precisely at 5 meters. And it won't depend on the maps. It will fly exactly at 5 meters altitude above the ground level.
Oh, okay.
Without collision.
Thank you.
Yep.
Then you need an extra hardware on the drone.
Yeah, absolutely. Yeah, we do install the extra radar, which looks down. We use it a lot with ground penetrating radars, because ground penetrating radars require very low altitude flights, like half a meter. So that's exactly the point. And it can be altered, yeah. Okay, so let's take a look at the video streams before we switch to Atlas. We have Atlas left, and yeah. Should I disconnect for now?
Still, I was expecting you to show us the result of the output, in which format? In drawing format, AutoCAD, or BIM, or which?
Yeah, so that would be the next piece in Atlas, right? So at this point, so if you think about UGCS is just a flight automation tool, right? So the data is being collected by the drone. It's a format of the drone. Right, so if we fly with pictures, if we collect the pictures, those are the pictures which you set up in a drone configuration. Later, when we stitch the map, it can be GeoTIFF or any other mapping formats. That can be done either in UGCS for simple mapping, or it can be done more complex in Atlas, and there are a lot of more formats to be out. But generally, we do rely on the drones. Right, so because we do just automate the operations. So if you think about UGCS itself, it doesn't collect any data. It's just a tool to ask the drone to collect the data.
There is one question for you from the live. Somebody's asking, is there any type of a scanner to scan the Dead Sea?
Bathymetric.
Yeah, there are. We have the sensor for bathymetry, which is a point sensor. It's been used for the service of the harbors and artificial lakes, but it's one point device. So that's integration we already have. It's basically one sonar which can go slightly into the water in one point and measure the depth. There are examples on the market, not from us, but there are examples of when the sonar, the sophisticated sonar sensors being attached to the drone and dragged over the water. These solutions are available.
And it can be on a boat.
It can be on a boat too, yeah. Yeah. By default, by the way, we do not really support drones in UGCS currently, or boats, yeah, boats and rovers. But when it's done using the open source autopilots, we can do it even without modification. Basically, the route can be planned without accounting for an altitude, and then it will operate. Or we can modify specific tools if needed.
Amazing.
So,
let me plug the HDMI cable.
Yeah, sure.
Sorry.
I think it's now been connected to me.
Oh, you have to.
Should I show it here?
What is the passcode?
Not sure.
And then it's connected to Extron, I think.
I need the passcode.
0787. No?
07.
Works? Yeah, you can stream it. Actually, I think I can show it on mine. If you press the stream button, because it's found my server.
Disconnecting or?
Let's see. Is this gonna work? Auto connected when it becomes always goes to you. Probably goes to you.
Streaming.
Yeah, streaming there. Okay, cool. So
just disconnect from your.
Yes. Yeah. So.
Okay. All right.
Yeah.
Amazing.
So what you see here on the screen now is basically the live video stream from the drone on UGCS server installed on the Yahya's laptop. Here, what you can do, you can check the latency. If you wave, you can understand how quick it actually goes. And by the way, count for the delay also, which we have between screen sharing, right? Because it's not an HDMI connected monitor, so there is some delay between the laptop and the monitor itself. But the delay between the drone and the UGCS server is very quick. What I can do from my side on my laptop, I can actually connect, since UGCS is just doing the restreaming of everything which comes from the drone, we can connect external systems. Like typical example in the security operations, we do connect Milestone and Genetech video management systems, which are used by security guys for their CCTV operations. There is an integration for that. And what do you think is an IP of us? 77, okay. Yeah. So yeah, what we can do here, and as you can see, basically I connected my laptop with just a video player, which takes the video stream from the video server of UGCS and shows it on my laptop. So you can do the same with any other system. If, for example, it's a command and control center, you can stream these videos to the main stakeholders, or you can stream it to this real-time artificial intelligence processing systems from every drone you operate. So that's very, I mean, for us it's kind of...
It is simple, to be honest, and there is no complexity in using it. Plug and play.
Can you locate the drone also?
Huh?
Can you see where the drone is?
Yeah, absolutely. One of the interesting things here that the video stream which we are taking from the drone is actually a geo-referenced video stream. So if you take this video stream into the system, which, for example, ArcGIS can understand this true motion videos. So we do stream true motion video from the drone. It's geo-referenced, so you see exactly where the drone is. You see each frame of the video in reference to the geolocation. It's all there. And plus, you can see the drone on the UGCS map. In fact, let me share my screen for a second.
All right.
Yeah, what you see currently here, you see this telemetry is actually coming to UGCS client is from this M300 drone, right? So the problem is we are in the building, so there are no GPS coordinates currently, so we can't see this drone on the map because GPS is 0. But if we take this drone out of the building right now, we will see the drone exactly on the map of UGCS, where is it located. So if you have many of them, you will have all of them. All the drones which will be connected to the system will be visible on the map in real time, working, flying, or standing, whatever. But the only thing is it just has to be connected. We don't see it now because GPS is not working here. But that's one of the things.
And as I'm seeing here, you can add up to 4 drones streaming as well?
Yeah,
source?
in one video server, we do support up to 4 streams at the same time. The reality is that the system is completely scalable. So if you want to have, say, 10 drones, 15 drones, what we do, we just install this video servers in parallel in the IT infrastructure. It's horizontally scalable, so you can have as many as you wish.
Amazing.
As I mentioned, we use this software also for the drone shows. So it's not only the video streaming from many drones, we do control thousands and hundreds of them at the same time. So and it's the same core system, it's just different user interfaces, but the core behind is absolutely the same. Yeah, so any questions so far? By the way, is any of you have a requirement to stream the videos in real time? Or maybe to do something else for the security? Okay, so then let's move to Atlas. Atlas is a second piece of software we want to talk today. As I mentioned, Atlas is basically AI tool to. Atlas is an AI tool to analyze the imagery which was collected by the drones in automatic mode. Just to give you an idea from the beginning, what are you going to visible bands? We can also analyze thermals, multispectral, or any type of image which can be delivered by the drone. Like in this particular camera, you have both thermals and visible. We can process both, but I have an example from visible one. Yeah, that's the first screen. How does it look like? It's a multi-user environment, so you can assign users with different roles. For example, you can say you have an engineer who logged in, you have a pilot. I'm now looks like both a pilot and engineers. For example, I have the tasks from the other people here, but it's not assigned to me currently. So there is basically a small task management system too. When the pilot logs into Atlas, he can see the tasks assigned to him by the analysis engineers or supervisors, and he will be able to mark the tasks as a complete or not. When I gathered the data as a pilot, it comes first as a basically set of images. Yeah. It comes as a set of separate images at the beginning. That's how we upload this from the drone to the system first. Location of these pictures taken on the map. This is a small area scan done not far from here in Dubai. You can select particular images here and see how do they look like, or you can click the image here. So this is initial thing which comes from the drone. That's what normally analysis engineers getting from the pilots. Now, when we want to process that, the system will basically stitch everything together. And now we are going, after the system will stitch it, we are going to have one big map with an elevation profiles. Let me do one thing first. Let me switch off this. Yeah, this is basically the stitched data. I did a simple thing. I did a photogrammetry scan with using the UGCS tool, and this photogrammetry scan was uploaded here. So currently, if you see the resolutions here, it's probably around 3 centimeters per pixel. So you can even see my vehicle with me standing here. That's what was done. And just for fun, I can tell you, it was simple Mavic Air drone. It's not even M300. It's a DJI toy. But you still, with this toy, you still have this kind of resolutions and the map available, right? So that's what is happening. Now, in red is a vegetation which was detected, right? So what I did to train the system, I selected a special training area. It's a bit slow. Yeah. So what I did here, I selected the red training area, and I marked the vegetation with the round circles, right, with the red circle. Objects are actually was located, like this 15,804 bushes are at the area. 32 bushes was used as a training examples, right? Obviously, I believe there would be now a question about how precise is that, right? And here exactly the example which you see. This one is not exactly precise because you see you have these are real vegetation detected, right? But in this area there is no vegetation. This is just the soil of the same color. Why does it happen? Because I trained the system only on 32 bushes located on the sand. That's it. So it obviously depends on the selection of the training data. Normally, when you really working in a real detection environment, what you do, you will use about 5% of objects for the training. Say if you have, say, 1,000 or 2,000 objects to find, you will use 50 to 100 objects to make sure the system is being trained. These detectors will stay with you forever, and one interesting thing that you can actually improve the detector later. So you trained it once, and you are not happy with the results. You did another survey a week later, and you can update the detector, train it again with a new data set, with a new background, and so on, right? So that's how detectors become better with the time. So basically, when it comes to first surveys, yeah, they are still a bit manual, but with later stages, when the detectors are improved by you,
it will be more accurate.
It will be much more accurate, yeah. And obviously, there are also some things about the backgrounds. Like here, it's very simple. Why I used only 32 bushes? Because the bushes are very well distinguishable from the sand, right? So background is really simple. When it comes to more complex cases, for example, when you want to detect date palms among other trees in a greenery, that won't be that easy. It really will require meticulous training to make sure that the system can recognize them, right? So but that comes with experience actually. It's a lot of things which can be done like this. Yeah. What else can be done? We can have here the change tracking. If I would have several surveys done in the same area in different times, the system will give you the change report, what's really changed in the area. There is also 3D views available of the area. But
you didn't use it.
Yeah, I mean, it's there. It's in the system by default. When you stitch the first imagery into the mapping, it will be available by default. Unfortunately, it's a bit slow on my laptop. I can't show the full, the full power of it. Yeah, you can see it's actually a 3-dimensional thing. And what these two lines are showing, you have a lot of measurements here. You have the cross-section tools, that's what you see. These two white lines, these two yellow lines is basically showing you the elevation profile exactly where the lines are drawn. So you have measurement tools like cut and fill report, so you can measure the volumes of the soil and objects in 3D. You can measure the area, distances, all these things. It's quite useful for construction and area monitoring currently. And that's been developed all over the time. So the good news about Atlas, it's a subscription-based system. Basically, we do introduce new features every 2-3 months. So it's not like you bought one version and you stuck with that. you get new features every 2-3 months. And what we normally do, we do collect the feedback from the customers, and once the list of the features requested from the customers is ready, we do implement them. That's basically simple.
Great. Pavel, we have a question from the streaming. What is the accuracy of the extracted trees with the training? Trees. In vegetation.
Yeah. Look, in the setup when you look for the bushes, right, or for the objects, there is a setup which you can filter by confidence interval. The only thing here, that's a confidence interval of a neural network, right, which was trained during our training. So it doesn't mean that we have 90% accuracy detection of the trees, but it does mean that you can actually alter that to make sure that the detection is more precise. There is no definitive answer, a generic answer for the precision, but the better you train, the better precision is.
We have another question as well. Can we detect the status of the trees if it's irrigated or healthy? Like,
it can be done with multispectral imagery.
This is a multispectral.
Yeah, it can be done. Visually it will be difficult. Visually we can detect the dry tree from the green one. Obviously that can be visually trained, right? But the health condition is multispectral thing. But we do work with multispectral images. So if you have multispectral cameras, it can be trained for that.
Of course, there is a solution from DJI for this. There is a DJI Phantom 4 multispectral. So this is purely for...
Yeah, exactly. So we can use this imagery and train the detector to make sure that we can detect healthy vegetation from unhealthy one. The same we can do with thermal imagery. So it's also possible.
Excuse me. Actually, it's a very interesting feature. My question is, for example, this is the, as you said, this is a 3 centimeter per pixel, right?
Here, yeah,
yes.
that was taken like this.
In a drone with a higher resolution, for example, 1 centimeter per pixel,
Yeah.
which is so. We can train it to find the objects on the ground. For example, there are several pollution on the ground, like a piece of steel, piece of plastic, piece of ceramics.
Sure.
So we can train it. It goes to recognize those things.
Yeah, absolutely. The Atlas, and I can share you the YouTube's links later. You can remove the vegetation from the terrain. So imagine if you scan some area and there is a vegetation, but you need the real terrain view.
The bare land.
Yeah, the bare land. Even without LiDARs, we still can detect the vegetation and remove it from the view, and then it will give real terrain inside. It's AI capability. It's not a replacement for LiDAR for sure, but it's just a good, quick tool in case it's needed quickly without additional scans. Yep. Obviously, the factory on the imagery, on aerial imagery, looks completely different from the drawing, right? But you need to have some reference. What can be done? The drawing can be added as a layer into the atlas, and you will see the overlay of the engineering drawings over the map. And you will be able to locate the imagery in the reference to the drawing. And then you can export it into DXF. DXF is basically ingestible by AutoCAD and can be overlaid there in the drawings. That's a typical workflow we use here. In fact, like construction progress monitoring, one of our biggest customers for that is Dell Construction in South Korea. They use Atlas for the construction monitoring a lot. And what they do, they train the detectors to detect building foundations, roads, technological roads, which are unpaved roads, different construction materials. And then detectors will work separately. And each detector will give it separate AutoCAD output. What they do, they overlay the output of Atlas, for example, for the road construction with the road plans. And they see how the progress in they are over the time. Amazing. And in Atlas, unfortunately, I don't have the data. I need to go there and fly one more time in this area. You can upload several surveys, and you can see them as the layers. You can see them as the time changes.
This is good for the progress.
It's good for progress and change tracking. Yeah, like you are growing something. Like again, multispectral imagery is a nice example. You have a farm growing some crops. You can really compare week by week what's going on with the field, right? Or in a construction, obviously, you can see.
There is a lot of
a lot of ways to use it. Any questions so far? Here, our colleagues from AMT probably speak to you more often than we are, but feel free to tell them where we will be connected and be with you.
Thank you very much.
Thank you for
Thank you.
participating.